Good morning once again, guys. So, can you hear me?
Yes, sir.
Okay, thank you. We complete our discussion on the file that we were using for the past few days on multiple regression. And so far, we have learned that when we do regression and when we model regression, and then if there are insignificant variables, we do not just remove them all at once. We remove one by one because it's possible that there might be collinearity among the variables, so that when you remove one, the other one becomes significant. So let's once again run the model. Let's backtrack a bit to model number 4. Okay, and I ran this already. I hope you have you run model 4 again. Kindly, if you have not done so, kindly run the model. Of course, you have to load the packages first, and then you have to import the wage data set that we were using. And once you have done that, you can now model model 4. We use the LM package. We use the LM function from the stats package, and we were modeling HR wage. We regressed this on education, experience, tenure, gender, and civil status. The other two, race and number of dependents, were already eliminated. We removed those two variables because they had the smallest t-stat. So when we run this, okay, we have here, looking at the overall goodness of fit test, your p-value is less than 0.05, which means that our model is okay. There's at least one variable that's significant to explain our dependent variable. And then we find out that there is one variable that's not significant, experience. The others are significant. Civil status is significant, however, at 10%. Okay. So what we did here was we compared model number 4 and model number 3. Okay, I didn't run model number 3 anymore, but we found out that model number 4 was better than model number 3. Okay, so take note, guys, I didn't jump immediately to modeling number 5. What I did was to check statistically if model number 4 was better than model number 3. That's why I asked here, is there a need to create a model number 5? Okay, we can still create a model number 5 because there is this other variable, education, experience, okay, experience, which is not significant. So, but before we did that, we had to check if model number 4 was better compared to model number 3. And indeed, model number 4 was better. Okay, so we proceeded to the next step, which is to create another regress hourly wage, this time on the 1, 2, 3, 4 remaining variables, by removing experience as a predictor. And the result is we have this. All the variables are already significant. Overall goodness of fit, guys, is okay. F-stat is 74.95 on degree of freedom 1, which is the number of predictors. Degree of freedom 2, which is n minus k minus 1. So that's 526 minus 4 minus 1. So that's 521. P-value is less than 0.05. Okay. All right. So this is our model. All predictors are significant. So what we do is we have to define each of this, the marginal effect of education, tenure, gender, and civil status on our dependent variable hourly wage. So for this one, we say that for every 1 year of education, increase in education, there's a corresponding $0.52 increase in hourly wage, ceteris paribus, which means that all things are remaining the same. For tenure, a 1-year increase in tenure yields a $0.15 increase in hourly wage, ceteris paribus. And for this one, gender male, okay, we know that on the average, male respondents received $1.71 hourly wage more than their female counterparts, ceteris paribus. And here, single respondents on the average received $0.68 less than their married counterparts, ceteris paribus. Okay, so this is our final model. Okay, so we can generate this Stargazer report and check. Let's see the AIC. Okay, so this is the Stargazer report. You can see here a side-by-side comparison between your model number 5, which is this one because there's no experience, and your model number 4, which includes the experience as a predictor. Okay, and we see that that the R squared for model number 4 is higher, 0.362 for the adjusted R squared. Okay, so this tells us that it's not necessarily that if the adjusted R squared is higher, that already means that that model is better. There are instances when the adjusted R squared is higher, a bit higher than the other one, but the other model remains to be the preferred model because of the R analysis of variance statistical test. Okay, so what others can we glean here? I also run the AIC and the BIC. Here you see that model 4 has a lower AIC, 2638 against 2639. So model number 4 is better compared to model number 5. But in BIC, model number 5 is better because it has the lower BIC. So sometimes these two will conflict. Okay, so which means, guys, that we cannot just use Akaike and Bayesian information criterion alone. We have to make use of other tests, and that's why the analysis of variance is a very good test. It's a statistical test to determine whether which of any two models is the preferred model. So by virtue of this analysis of variance, we know that model number 5, the restricted model, the one with the less number of predictors, is the preferred model. Okay, so I wrote the model here. Unfortunately, I don't know why it's not working. Wait, let me see. May quirk minsan tong LaTeX na okay. Is it running, guys, yung code na to? Nagra-run ba sa inyo? Paki-chat nga kung nagra-run sa inyo yung code. Yung LaTeX version. Okay. Nagra-run ba sa inyo? Okay. Oo nga. Bakit kaya hindi sa akin? Anyway, so I just wrote the final model, guys. Okay, so paper nyo, syempre, isusulat nyo rin yung final model nyo. By the way, guys, sa paper nyo, kasi you're required to do the knitted file, pretend as if it's a paper, no? Parang thesis nyo kunyari. So, hindi dapat lahat ng codes, guys, nag-a-appear sa paper nyo. So, may mga codes, guys, na dapat ilalagay nyo sa appendix. Nakalimutan ko pala, guys, sa last part, the appendix sa knitted file, andun dapat lahat ng ng codes, no? Especially those that need not ba't naging ganito to? Need not be included in the body of the paper. Okay, kasi may body yung paper nyo, tapos mayroon ding appendix. Nakalimutan ko lang, guys, take note na may appendix dapat yung paper. And yung sa appendix doon, guys, doon mag-a-appear lahat ng mga codes. So you don't have to put all the codes in the body. Siyempre dapat mag-a-appear yung code doon kaso naka-format, naka-ano siya dun sa settings na hindi siya dapat mag-appear dun sa body mismo. Okay, kuha niyo yan guys. Paki-chat nga kung clear yung instructions na yun. Okay, good. Thank you. All right, so let's move on guys. Let's continue. Okay, see? Okay, thank you. So let's continue. Okay, so this one guys is one way you can do the write-up for your paper. Parang summary siya. Yeah, correct, Gracia. Yung may question si Gracia dito, in the appendix, it's like the whole RMD file. Yung codes, yung codes lang. Kasi pwede naman natin, 'di ba, sa RMD, pwede naman natin ilagay lang yung codes without the output, 'di ba? If false natin yung output, ibig sabihin ando doon lang yung code kaso hindi ma-generate yung output. Doon sa body naman baliktad, no? Yung mga portions ng ng paper natin, ilalabas natin yung output but not the code. Okay, so I hope that's clear, no? Did that answer your question, Gracia? Okay, sige, thank you. Okay, then of course, guys, we don't just stop there, no? We do diagnostics. We might not be able at this time to remedy the model, the violations of the assumptions, but at least guys, alam natin kung may violation tayo ng linearity, kung may violations tayo ng heteroscedasticity, ng normality. What's important is that na-identify natin yon. Hindi pa natin na-discuss guys, and we will not be able to discuss it here. That will be discussed in your next subject. How do we now address yung mga violations ng assumptions ng linear regression? So for example, dito, plot 1, obviously guys, ano sinasabi dito about residual analysis? Okay, ano ba sinasabi ng plot 1 dito when we plot residuals and yung fitted values dito? It tells us of the linear relationship between your your dependent variable and your independent variable. So here it tells us that mukhang may problema dun sa linearity assumption, no? And you can see here also, kitang-kita natin dito yung violation ng homoscedasticity, no? Although kita din to sa plot number 3. Ayan, no? Kita nyo guys, there's non-constant variance. Okay, then also there's a possible presence of influential points, no? May mga outliers tayo and possible influential points. Okay, then plot number 2, normally distributed by yung residuals. Okay, oops, sorry. This should not be plot number 1. This should be model 5 pala. Model 5. Model 5 ba yung kanina? Okay. Model 5. Okay, so we see here guys na clear violation to ng normality of residuals. Okay? Okay, I don't expect in your paper guys to for you to address that. Pero mas maganda guys kung may there are ito guys, this is a soft requirement yung normality ng residuals, no? So mag-research kayo guys ng you will be able to find possible reasons or justifications na kahit na hindi normally distributed yung residuals, okay pa rin. For example, pag malaki yung sample size, no? Okay lang kahit na yung residuals natin not necessarily normally distributed. Okay, then ito yung homoscedasticity natin. We have shown this already. Oops, sorry model 1 pala nakalagay dito. Model 5. There, no? Kita naman sa plot guys, ng standardized residuals at saka ng fitted values natin. And there's non-constancy invariance. Kita nyo guys yung fanning effect. Parang fan siya, F-A-N. Lumalaki, no? Lumalaki. So, violation dyan ng ng constancy of variance. And then I think guys, tinest natin statistically kung heteroskedastic nga errors natin. And we did this Brusque-Pagan test. So this is your Brusque-Pagan test. Yan. And it turns out that p-value natin is less than 0.05. And then again, revert to your null hypothesis. The null hypothesis here is that the residuals are constant or homoscedastic. So we reject this. So true enough, guys, meron tayong statistical test na nagpapakita na yung error terms natin are heteroskedastic. Okay. Then influence points. Sorry. Influence points natin. Okay, we can see here based on the Cook's distance, no? 0.260, 59, and 112 seem to be influential points. There's a way to address that, but we won't look at that here. Of course, in your paper, guys, pwede kayo maglagay ng comments about this. No? I'll give extra points kasi may points yung diagnosis dun sa paper. So if you go one step ahead and then try to address that, that will be good for your self-knowledge then. Okay, then ito yung influential points natin and outliers, yung Cook's distance. Mali na naman yung model ko. So we have it here. Okay? So lagi consistent to, so 112. Siya yung pinakamalaking Cook's distance. Okay, so how do we may formula yung Cook's distance, ano? Tapos the way they determine kung possible influential point to is they compare this with the 4 over n minus k minus 1. So kung lumalampas dun, that might be a candidate for influential points. So anong ginagawa usually pag yung influential points na yan, pwedeng if you try to remove that, no, and then you regress the model again, makikita natin that it's possible that it will greatly affect the model itself, your regression model. Okay, so now we go, guys, to stepwise regression. Sabi natin, when we model, tapos may mga insignificant variables, we don't remove all of them at once. No? So there are different ways sa stepwise regression. Meron tayong forward. Okay? Meron tayong forward regression, meron tayong backward, and then meron tayong tinatawag na stepwise mismo. So for R, we're going to use the OLS-RR package. So there are, we first look at forward regression. And there are 2 ways to do forward regression. Merong using p-values. So we will identify kung ano yung cutoff natin, kung ano yung level of significance natin. And there's another way called the AIC method. No? Ito naman ang basis para ipasok mo yung variable as a predictor. Ginagamit natin yung AIC to determine if a particular variable should be a predictor. Ito naman ang ginagamit natin yung p-values. So pwedeng guys, pwedeng mag-conflict yung dalawang yan, no? Pwedeng iba yung result ni forward regression using p-values vis-a-vis AIC. So here once again, guys, i-model natin ulit. Let's call it model. So we're modeling HR wage on all our predictors, kasama ulit yung 7 predictors natin. And then we create an object forward fit.p. Okay, ang function na to OLS step forward. Okay, so this is coming from OLS-RR. And then model natin and then define natin kung ano yung level of significance p enter. Okay, so let me run the last 2. Okay, run natin, control enter. Okay, so meron na tayong forward fit.p. So it's a list, guys. It contains many items, 11 items all in all. Kunin natin summary. Okay, let's get the summary. Okay, naran ko na to kanina. Pakiran to, guys. Forward fit.p. If we run this, okay, this is what we'll get. Okay. What do you notice, guys? Sa forward regression, guys, ang una, isa-isang linalagay yung ano, isa-isang pinapasok yung ano yung variable. So the first step is education munang pinasok. Most probably, I'm not sure, but most probably ang candidate na yan, guys, will be, of course, ang candidate na to will be the one that will give the least adjusted R squared, no? The greatest adjusted R squared. So education muna, ang R squared 0.1648, no? Adjusted R squared 1632. Now there are other measures here. Ito yung Mallows CP. Okay, parang AIC din to. Pero ito ang gamit ito, guys, for measurement of bias, no? Parang related sa AIC at saka sa BIC natin, no? And then we have this ito pala Akaiki, and then yung root mean square error. Okay? Just like ito mga to, si Mallows, Mallows, ulit ko MALLOW, no? Mallows C, no? Parang AIC din yan at saka RMSE, the lower the better. Pero sa adjusted R squared, the higher the better. Okay, so summary to, guys, selection summary. Ang susunod na pinasok, tenure. Okay? Tenure yung susunod na pinasok. Okay, so pag pinasok yan, ibig sabihin yan, guys, statistically significant yung dalawang to, no? And nagtumaas yung adjusted R squared natin, naging 29.9%. And then third variable na pinasok, gender. Okay, tumaas yung adjusted R squared natin. And finally, civil status, 36.04. Wala na siyang pinasok, guys, na susunod na variable kasi hindi na significant yung variable na pag pinasok pa. This is based on p-value, no? P-values. Kasi define natin ang papasok lang basta yung p niya, okay, basta yung p niya is less than 0.05. Okay, pause muna ako. Any questions with that, guys? So dito we can see here that si OLSRR na the package will already provide for us the forward stepwise regression. Okay, any questions? Paki-chat naman, guys, kung clear so far. Okay, thank you. Yung iba, may comment ba yung iba? Okay, thank you. All right. There's another forward regression, guys. This time, it's using AIC naman, no? So, kanina ang ginamit, p-value. Ngayon naman, AIC. Ano ibig sabihin yung ginagamit ng AIC? For as long as bumababa yung AIC, ipapasok yung variable na yon. Even if hindi siya significant at 0.05. Okay? Siyempre, guys, related pa rin yan, ano? Hindi naman maglalagay ng independent variable na talagang masyadong malayo yung masyadong hindi significant yung p-value. Kasi may relation yung dalawang yan. Kaso minsan, maliit lang yung difference, no, between the result using p-value and the result using AIC. Okay, tingnan natin, ha. So this is now our model. We create forward fit.aic, and the function there is OL step forward AIC. Kanina yung function natin, OLS step forward P. No? Ito naman, OLS step forward AIC. Okay, so let's run this. Let's run the model. Okay, so we will have this now, forward fit AIC, and this is the result. Okay, if you take a look, guys, dito, 5 yung natin, predictors natin. Kasama yung experience, no? Kasama yung experience. Okay, now, Naranan natin kanina to eh. Ito yung model number 4 natin, where experience was significant at 10%. No? So doon kanina sa forward fit na p-value na ginamit natin, hindi niya pinasok sa experience kasi yung p-value niya greater than 0.05. Kasi ang sinabi natin, ang p-enter natin dapat 5%. 5% yung ano dapat yung probability. Now ito kasi AIC. Now, you notice guys, habang nagpapasok siya ng panibagong variable, lumiliit yung AIC. Hanggang sa experience, no? 2638, mas mababa yung AIC kung may experience compared to hanggang civil status lang. So that's why pinasok niya dito based on that parameter. So dito, ang P natin dito, ang level of significance na tinanggap natin dito is 10%. Kasi we know, doon sa previous na ginawa natin, sa experience had a level of significance, mga 7% yata. So dito sa method na to, hindi niya kinonsider yung p-value, ang kinonsider niya yung AIC. So that's why you're having a different model as compared to the first one, yung first forward natin na hanggang hanggang civil status lang. Okay, so let's plot this, guys. Let's plot the relative contributions of the predictors dito. Okay, tingnan natin dito ha. So ang pinaplot dito si AIC, no? Notice as kung isa lang yung gagamitin natin ng predictor education, 277 something yung AIC. When we included tenure, bumaba yung AIC by this much, no? When we included gender, it went down, tapos civil status, tapos hanggang experience. Now, pag ipapasok pa natin yung isang variable which was number dependence, tataas na yung AIC niyan. Okay? Plus, pag pinasok pa natin yung yung race, tataas pa ulit. That's why hindi na sila pinasok. No? Okay, clear yan, guys? Okay. Now, if you want all the steps, no? Okay, thank you. Kung gusto natin, guys, na lahat ng steps ipiprint, okay, ilalagay lang natin dito, details is equal to true. So, pag rinan natin to, makikita natin, guys, yung step-by-step forward selection. Okay? So, ito sinasabi, candidate terms natin. Okay? Candidate terms natin, itong pitong regressors natin. And then, okay, unang-una, step 0. Okay? So, what do we have here? Ano ibig sabihin ng early wage regress on 1? Pag ginawa nyo to guys sa R, no, regress on 1, ibig sabihin yung intercept lang yan. Okay? Yung intercept lang. Ibig sabihin, wala tayong ginagamit na predictors. Parang ito lang yung average na ng average ng HR wage, no? AIC is 2870. Kung wala tayong gagamitin na regressor, step 0 yan. Ang AIC natin 2870. Okay, and then sinasabi sa atin dito, kung education ang gamitin natin, ipasok natin, ang AIC natin 277. Kung tenure ang ipasok, ito yung AIC natin. So you see here guys, ito na yung listed, no? In order guys, ano mangyayari sa AIC kung ang ipapasok natin si race, it will be 2871. Eh wag natin ipasok yan kasi mas maganda si education na 277 yung yung AIC. Okay, gets guys? Gets? Also guys, adjusted R-squared, mas maganda kung ang unang ipapasok natin si education kasi it has the highest adjusted R-squared. Okay, so in terms also of RSS, this is the sum of the squares of your residual, pinakamaliit siya, no? Dito ang ginamit niya, RSS, residual sum of the squares. So yung squared residuals, 5980 dito, yung raised, 7149. Okay, so kaya nga education yung unang pinasok niya. Kasi pag education ang pinasok natin, it will have the lowest AIC, it will have the highest adjusted R-squared. Okay, next. Kasi forward regression to, di ba guys? Sa forward, ang nangyayari, one step at a time, nagpapasok tayo. Unlike yung backward, ipapasok lahat tapos one step at a time magtatanggal. Okay, then next. So nag-plus education na tayo, no? So ito na yung result, guys. Hourly wage, regress on education, AIC natin 277. Okay. So when that happens, ano mangyayari? Okay, ito na yung next, no? Next candidate. Pag pinasok daw si tenure, ito magiging AIC, bababa, no? Tataas din yung adjusted R squared. So ang ginawa niya sa susunod, pinasok sa tenure. So ang naging model natin, hourly wage, regress on education plus tenure, tapos si AIC natin bumaba, naging 2685. And so on, guys. Ganon, no? Isa-isa siya. Susunod naman si gender. Okay? Gender. So pag dinagdag si gender, tatlo na sila, bumaba ulit yung AIC, gender, pinasok si civil status, okay? 2639. Pag pinasok daw sa experience, magiging 2638 yung AIC, kaya pinasok siya ulit. Okay? Plus experience. So ito na yung regression model natin. Okay. Pag pinasok pa si number of dependents, guys, 2638.6 na tayo dito, magiging 2638.809. So tataas yung AIC. Okay? Tataas yung AIC pag ipasok pa natin si number of dependents. Therefore, ang sabi dito, no more variables to be added. Okay? So wala nang dinagdag. Sinamarize siya, variables entered. Okay? Final variable output. So we have here some measures. Ano yung correlation, no? This is what we call the partial correlation. R squared, adjusted R squared, predicted R squared. Okay? Root mean square error, etc., etc. Mean square error, mean absolute error. Okay? Ito yun. Okay? Kindly check na lang, guys, kung anong mga ibig sabihin to. Ano din yan, yung they're also used in order to compare models, no? Root mean square error simply. Square natin yung error, tapos kunin natin yung kunin yung average square root. Okay? Yun lang yun. Root, mean, square muna, then squared, and then kunin yung average, and then kunin yung square root. Root mean square. Alright? So this is now our ANOVA, no? Ito na yung ANOVA natin. What's this, guys? What's this? This is your SS, R, SSE, no? Then you have here degree of freedom, 5 kasi 5 predictors. Alam natin kukunin itong degree of freedom 2. Mean square is simply this divided by this. 2636 divided by 5, ito yun. 4524 divided by this, ito yun, no? Okay, sa finals nga pala, guys, pwede ako magbigay ng table, no? Kaya dapat panoodin yung Excel, guys, ha? Kasi pwede ako magbigay ng table ng ANOVA, tapos you have to know how to compute for this one. Okay, so please watch the Excel, the videos which I posted on regression using Excel. Kasi definitely may question, guys, sa finals nyo na may mga blanco to, then solve nyo. Okay, then parameter estimates natin, we know how to understand this already. So this is your coefficient, no? Ito na yung mga 5 predictors natin. Beta is the coefficient. Standard error, T-stat, level of, kung significant ba, take note here, guys. Si experience, no? In fact, yung p-value ni experience, 0.12. Okay, 0.12 siya dito. Okay, so si notice itong mga significant, guys, hindi tatamaan si 0, no? So ito si civil status dito, it looks like insignificant din siya, no? Kasi pwedeng tamaan si 0, but because by virtue of the AIC, ginawa pa rin siyang significant. Ginawa pa rin siyang part of the predictor, sorry. Okay. Ito na tayo, guys. Any questions? That's for a forward. Okay, we have to pace ourselves kasi, guys, kasi limited lang time natin. Any questions, guys? Clear so far? Paki-chat naman, guys, kung clear. Okay, thank you. Yung iba? Okay. Thank you. Thank you. All right. Okay, good. Thank you. Okay, now we go to backward, no? So forward, guys, ang nangyayari sa forward, isa-isang pinapasok, no? Dalawang basis, either p-value, pwedeng ipasok kung significant siya sa model. Tapos yung isa naman, yung AIC. Related siya, no? Related sila. Only that nagkaka-difference lang sa last kadalasan naman pareho silang parehong output, but minsan nagkaka-difference sila kasi pwedeng maging bumaba yung AIC pero hindi na significant yung independent variable na yun, yung predictor variable. Okay? For our purposes, guys, we'll just stick to the p-value. No? So we'll strictly enforce the 0.05 level of significance. Sa paper nyo yung ang gamitin nyo. Okay, but if you're going to use this in your paper, syempre, explain nyo lang yung difference. No? Okay, let's go to backward, guys. Ganun din, gagamitin natin si model natin where we're regressing HRH on all the predictors. Okay, so we'll create an object backward fit.p. P-value yung gagamitin natin dito. P remaining, ibig sabihin, yung kanina P-enter, pwede siyang pumasok kapag yung p-value niya dun sa model less than 0.05. Ito din, ganun din. Kaso dito, pag backward, guys, ang function dito, OLS step backward, remaining, no? Remaining. Okay, so let's print this. Okay, so this is what we have, guys. Bakit ganito? Wait, ha? Model. Weird. Sandali, guys, ha? Kasi, bakit Bakit tatlo lang yung Dapat apat to eh. May nakikita ko yung mali sa ko, guys? Model, tingnan ko lang yung model natin, ha? Tama naman yung model natin. Model is model. So lahat naman, no? Dot. Okay, sige. Let's just continue. Let's see. Baka may kasi dapat si backward. Ay, sorry. Sandali. Okay, mali. My mistake, guys, ha? Mali yung pagbasa ko. Ito, guys, ito yung eliminate, no? Elimination summary pala to. Sorry, for a while, I thought ito na yung predictors natin. So, first na eliminate si race. Okay? Tapos pangalawang in-eliminate si number of dependents. Tapos pangatlong in-eliminate is experience. No? Okay? So, eliminated. All right. So now, let's using the p-value method. Ito naman yung AIC. So let's run the AIC method. So tingnan natin kung anong in-eliminate niya. Okay, so dito sa backward guys. Okay. So dito pareho lang, no? First is the full model. And then, sa AIC guys, dalawa lang yung tinanggal, no? Which is consistent with the forward kanina. Forward using AIC, 5 predictors natin, di ba, kasama sa experience. Ito, full model muna, lahat ng variables, AIC 2640. Pag tinanggal si race, magiging 2638. So bumaba yung AIC. Pag tinanggal si number of dependents, naging 2638, no? Okay? Pag tinanggal pa ulit yung isa, tataas na yung AIC. Okay, so dalawa lang guys yung in-eliminate natin. Kasi di ba sa backward stepwise regression, you load the full model and then you remove one by one. Ito yung sabi natin yung pinakamaliit na absolute value ng t-stat. So yun ang tinanggal niya. Same sa ginawa natin kanina, yung race muna, tapos yung number of dependents. Okay, so i-plot natin guys tong backward, no? Let's plot this. Okay. So just the same here. Full model muna. AIC ito. Nung tinanggal si race, bumaba, no? Tinanggal si number of dependents, bumaba. Pag tatanggalin pa natin yung isa, which was experience, tataas ng konti yung AIC. So that's why dalawa lang yung tinanggal based on backward stepwise regression. Again, guys, ito yung yung intermediate steps. We just add to our model details is equal to true. No? Isama lang natin to sa code natin. So pag sinama na natin, okay, again guys, backward elimination method, candidate terms, lahat ng variables natin. So what happens? The first step is everything is included in the model. Pasok lahat sa model natin. Okay. So dito sinasabi guys, step by step, kung tatanggalin si race, si AIC magiging 2638. Kung tatanggalin si education, si AIC magiging 2749. So syempre, the smaller the AIC, the better. Ang unang tatanggalin si race. Okay? So then, susunod, variables removed, tinanggal si race. X, race. So sa step 1 natin, ito na lang AIC natin, tapos ang model natin, anim na lang siya. Wala na si race. Next step, ang sinuggest niya, pag tinanggal si number of dependents, okay, ang AIC natin magiging 2638.6. So magi-improve yung AIC natin. Pag ang tinanggal natin si education, guys, AIC 2748, tataas compared to the current AIC na 2638. Okay? Pag tinanggal natin si civil status, tataas din yung AIC. Magiging 2639. Currently, 2638 tayo. So tatanggalin natin si number of dependents, kaya nga X, number of dependents. So bagong AIC natin, 2638. Tapos 5 na lang yung ano natin guys. 5 na lang yung mga predictors natin. Okay. Pag tinanggal natin si experience dito, 2639.05. Currently ang AIC natin, 2638. Okay, so tataas yung AIC. Remember, this is AIC based, no? AIC based to. So, okay, no more variables to be removed. Okay, kasi pag tinanggal pa natin si education, si experience, tataas lalo yung AIC. Okay, so ang remove lang si race at saka si number of dependents. Okay, and then we have model summary. Okay, mineasure yung RMSE, MSE, etc. Okay, then we have the ANOVA, overall goodness of fit natin dun sa 5 remaining regressors. Okay, no? Significance at 0.00, no? Ibig sabihin nun, remember ano yung null hypothesis ng ANOVA? Beta null is equal to beta 1 is equal to beta 2 hanggang is equal to beta 5 is equal to 0. So that's our null hypothesis. And we reject the null hypothesis that all of these variables are equal to 0. There is a statistical. We are confident that at least one of these is statistically significant. Okay, paano nga pala na-compute itong F na to dito? MS. This is called your MSR. This is called your MSE. No? Dali, sulat ko yan guys ha. Yung mean square doon. MSR mean square regression, and MSE mean square error, or this is your residual. Then your F stat. Okay, dinivide lang yun, no? Okay, the reason why I'm saying this, guys, kasi nasa Excel discussion yan, ano? And you need to know that kasi lalabas sa exam yan. Okay, sana tayo. Asa na yung ano natin, yung ito, no? 527 divided by 8.7, that's 60.06. Okay? Hirap Okay. By the way, guys, ano to? This is your SSR. This is your SSE. This is your SST. No? We know how to compute this, di ba? Okay, degree of freedom, then MSR, MSE, FStat, then ito, yung ano, nakukuha natin sa table to, no? Yung p-value. Okay, so, saan na tayo? Okay, pwede nating na-plot na ba natin to? Okay, stepwise regression. Note this, guys, stepwise regression, no? Okay, si forward stepwise regression, you put in a variable one at a time. Okay? Si backward regression, guys, you put all and then remove one at a time. Pag remove mo na yung variable, guys, hindi mo na siya pwedeng ibalik. Itong stepwise regression, okay, anong nangyayari dito? Pwede kang magpasok at saka pwede kang magtanggal, tapos pwede mo rin siyang ibalik afterwards. So, yun ang stepwise regression, medyo mas complicated, no? So, i-run nga natin to, guys. Both fit using ALS. So, OLS step, hindi forward, okay? Hindi backward, pero both. So, what happens here? Okay, so dito, guys, okay, sa stepwise regression na to, ang mangyayari dyan, titingnan niyo muna ano ipapasok niya, tapos pag may ipasok ba siya, pwede siyang maipasok na iba tapos ilabas, no? So pwedeng ganun. Ang nangyari dito dun sa stepwise, isang lumabas lang, no? Walang ganun na nangyari, addition ng lahat. Ibig sabihin, halos forward regression lang din to, no? Education muna pinasok, addition. Tenure pinasok, addition. Gender pinasok, addition. Pwede, guys, magkakaroon ng addition tapos may subtraction din, no? Pwedeng may tatanggalin din dito. Ganun sa stepwise regression. But it turns out here that walang ganun naging nangyari. Okay? So, i-plot natin to. Both fit. So, anong nangyari, guys? Both direction selection. Education muna. Tapos sinama sa tenure. Bumaba yung AIC. Sinama si gender. Sinama si civil status. Sinama si experience. So, in this case, si stepwise regression, pareho lang ni forward. There are instances, guys, na may combination to, no? May pinapasok, tapos may tinatanggal. Okay? Kasi sa backward, pag tinanggal mo yan, hindi na pa pwedeng tanggalin ulit. Touch move na yun. Hindi na siya pa pwedeng tanggalin, no? Ibalik. Okay? Pag backward, may tatanggalin ka, yung tinanggal mo na yun, later on, hindi mo na siya pwedeng ibalik. Kasi sa stepwise, pwede yun eh. Okay, so may question si Paul. Paul, paki-post sa ano? Oo, Paul. Ang question ni Paul, paki-post sa ano? Sa everybody. Okay, may comment si Paul. Pwede? Ayan. Okay. Paul, paki-post to everyone. Yeah, oh, but it's a good observation. Tama, yan. So, ang observation ni Paul, stepwise appears to be a forward regression because a predictor is being added one at a time. Okay, that's correct. Nagkataon lang yan, guys, ha? Kasi ang stepwise, pwedeng may pinapasok at saka tinatanggal and then binabalik ulit, no? Yun ang stepwise. So, actually, it's a more comprehensive, it's a more comprehensive method. However, dito nagkataon lang, guys, na si stepwise, wala siya nakitang gano'n na pinasok niya, tapos linabas niya, tapos ipapasok ulit. Or tinanggal niya, tapos ibabalik niya ulit. Wala nangyaring gano'n. Okay, but that's the nature of a stepwise regression. So may mga instances na nangyayari yon, but not in this case. Okay? So your comment is correct. Dito yung stepwise regression natin, parang forward lang. Alright, then, ito guys, all possible, no? Saan na siya? Ito yung intermediate steps. Let's just take a look at this. Okay, intermediate steps guys. Again, ibig sabihin to hourly wage regressed on 1. Pag ginawa niyo yan sa R guys nga pala, ang mangyayari niyan, it will just be the intercept. No? Sige nga sandali para kasi mukhang hindi ko nasabi sa inyo, nakalimutan ko sabihin sa inyo. Okay, I'll just, ito lang guys, no? Insert R. Ilagay lang natin yon, just Control C. Lagay lang natin ano, mod 100, no? Mod 100. Then we use LM function. LM, okay? Oops. LM. And then data is equal to wage. Okay, let's see what happens here. Litan ko na lang yung ano. Pwede naman capital, wala namang problema yun guys. Pero I'll just make it small. Okay, summary mod. Okay, what happens guys if we regress 1 yung ginamit natin na regressor. Okay. And guys, intercept lang, no? So we're not using any predictor. Okay, we're using just parang average lang to, no? If you notice guys, ano yung average na hourly wage? It's 5.9. It's this one. 'Di ba? Ito yung pinanggalingan yung sa SST natin, yung predictor natin yung average lang na hourly wage. Ito 'yon. Okay, so balik tayo dito. We need to finish this already kasi let's have 15 to 20 minutes for logit, no? So what happened here guys? Ganun din, no? Nag-plus siya dito. Ito muna yung model natin, yung ano lang, full base model lang natin, wala tayong ginamit na predictor. And then ito yung mga entering variables natin. Okay, ang hirap ito yung mga entering variables natin guys. Okay, so what happened here was kung ito yung papasok natin, again pareho ng ng forward. So plus education and then plus tenure. Okay? Plus gender, plus civil status, plus experience. Final model natin ito. So in this case, guys, sabi natin okay. So makikita natin dito sa stepwise remove existing, no? Ano ibig sabihin nito? Remove existing. So ito yung model natin, education, tenure, gender, civil status, plus experience. Pag tinanggal natin daw sa experience, ang magiging AIC natin is, AIC is 2639, okay? Ngayon, 2638. So, wag daw tatanggalin sa experience kasi bababa tataas yung AIC. Tapos dito naman, pag nag-enter pa tayo guys, okay? So take note dito, yung final report, magsasabi siya kung ano mangyayari kung magtatanggal tayo ng existing o mag-enter ng new variables. Okay, that's the nature of stepwise regression. No? Okay, ito wala tong report na to dun sa forward natin at saka sa backward. Okay, so I hope that's clear guys. No? All right, no more variables to be added or removed. Notice, no? Dun sa forward, no more variables to be added. Sa backward, no more variables to be removed. Dito, no more variables to be added or removed. Okay, so may final model tayo. Okay. All right. So ito yung ano natin, yung individual test, no? Individual t-test. Ito yung coefficient siya. T-stat significance. Again, ito yung na-point out na natin to kanina. Okay, then last guys, ito. Now, what's good about OLSR? Gusto mo ng lahat ng possible na regressors? Ito yun. All possible subsets. Now, sandali. Ilan ba yung ano guys? Ilan yung predictors natin? Ilan yung predictors natin? 7, di ba? So, ilan yung possible na predictors, yung combination? It's 2 to the 7, 2 to the k, no? 2 to the k. Kung ilan yung predictors mo, 2 raised to the predictors, since we have 7 independent variables, so 128, lahat ng possible combinations. Kunyari, ibig sabihin nun, tigi-isa lang sila, 2, 3, combination ng 3, 4, 5, 6, lahat, no? 128. So, i-run natin to, guys. I-run natin. So, here we're told that 128 possible combinations, ano? So, all possible combinations, OLS step, all possible ng model natin. Okay? It will take time kasi 128 lang, guys, lahat yan. Tingnan nyo, to. Tingnan nyo na to. No? Andali, I'll increase this para mapakita na rin si Mallows. There you go, guys. So, ito, predictors, R squared. Ilan lahat, guys? Ilan lahat? Ilan siya lahat?
Sir, 127 lang po kasi
127 lahat.
yung pang
Bakit
120.
127? Bakit? Sabi natin 128.
Yung pang
128 kung isasama natin yung walang predictor, no? Yung regressed tilde 1, bali yung average lang ng hourly wage. So all in all, 128 possible values, possible predictors, pero dito hindi na sinama yon. So you see here guys, index. 1, ito, tigi-isang variable lang ang predictor. Kita niyo guys yung n. Okay, so here you have 2, lahat ng 2 possible predictors. Okay. Then you have 3 possible predictors, yung mga combination nila. No? And then 4, 5, 6 possible predictors. So lahat yung 7 guys, ito na yung full model natin. Iisa lang siya siyempre. No? Okay, clear yung paki-chat nga guys kung clear tong all possible models natin. Okay, good. Alright, tapos may measure dyan. Nakalagay dyan yung measures natin ng yan. Based on adjusted R squared, sino yung pinakamaganda? Based on Mallows CP. No? Si Mallows CP, guys, it's a measure of bias. The lower, the better. Okay, asan ba yung ano natin, yung full model natin? Yung full model natin yung 4, di ba? 4. Ito yun eh. Andito siya sa 4 na possible combinations. Asan siya? Education. Hindi. Madaming 4 din kasi, no? Saan siya? Okay. Medyo mahirap mahanap. Okay, thank you. So, sa 4 na variables, guys, tignan nyo yung mga Mallows CP nila, matataas. Dapat mababa lang yung Mallows CP. No? So, let's see. Ito. Siguro dito yan. Ayan. Mallows CP, 4. Okay, ito yung... Okay, so in-arrange siya, guys. In-arrange niya yung lahat ng 4 na predictors. Okay, sorry. I missed that. In-arrange siya from the best na 4 predictors by virtue of ito yung adjusted R squared. No? Tingnan nyo yung adjusted R squared bumababa. At saka yung Mallows CP. No? 6.2. Ito yung pinakamababa dun sa mga 4 predictors. No? 6.2 siya yung best. So the way this is arranged is that lahat ng mga 4 predictors, ina-arrange yan from best to worst based on R squared, adjusted R squared, and Mallows CP. Okay? Alright, kung titingnan natin yung 5 guys, ito yung model natin, no? Yung may experience. No? Ito. Okay, adjusted R squared na 0.3621 and then Mallows 5.83. Okay, so that's how this is done. Okay, and then tapos sana tayo. Okay, ito na, no? And then compare natin, guys. Let's run this. Oops. What does this give us? Okay, if you take a look at this, so page 1. Okay, page 1, based on R squared. Ano ibig sabihin nito, guys? Based on R squared, kung isa lang yung predictor, si index 1 yung pinakamaganda. Sino ba si index 1, guys? Number 1. Ito yun. Kung isa lang yung predictor, guys, sabi niya, ito. Si index 1 yung gamitin natin, si education. Siya yung pinakamaganda. Okay, I hope you got that. Pag dalawa daw yung predictors, ang gamitin si 8. Sino ba si 8? Index 8. Index 8. Ito siya. So notice siya yung pinakauna sa dalawang predictors, guys. No? Education tenure, ang pinakamaganda kung dalawang predictors lang, etc. Okay, I hope you got that, guys. Very, very informative to. No? Okay. Kung 5 daw yung 5 yung predictors, index 99 ang gamitin. Ito naman based on CP, kung isa lang yung predictor, 1, kung 6 yung predictor, 120, kung 7, 127. I think this 127. So also based on adjusted R squared, based on AIC, pino-point out sa atin dito kung sino yung pinakamagandang model based on the number of predictors. Kasi all possible to, di ba? Ganun din kung SBIC, Schwartz-Bayesian Information Criterion, Schwartz, halos pareho lang naman to, no? SBC, SBIC. Okay, so, okay, you have here some references. Okay, that's it, guys. That's it for your stepwise regression. Any questions? Clear ba, guys? Clear tayo? Oh, guys, important to. This will give you a parang advance sa FinStar, no? Kasi regression yung pag-aaralan nyo eh. So, ang laking tulong nito sa regression. No? Okay, good. Okay, so isa lang yung sumagot, guys, kung clear. Kung pwede, pakichat naman kung clear so far, guys. Okay, thank you. Alright. So, i-budget natin time natin. Okay, salamat ha. Pakipasok, guys, sa diagnostics pa pala, no? Okay, ito, guys, hindi ko masyado ng masyado ng i-discuss. Anyway, ang dami namang dito, nakalagay na, no? Naka-discuss na. So here we're using the from the package Datarium, no? May data na marketing. I-run natin to. And then i-run natin si data marketing. And then yung head na lang. So itong data na to, marketing, meron siyang 4 na variables: YouTube, Facebook, newspaper, and sales. So mukhang obvious naman yata na si sales, ang dependent variable natin. We'd like to see how sales is influenced by advertising in YouTube, Facebook, or newspaper. No? So structure, numeric lahat, summary. Bibigyan lang sa atin yung 5 number summaries natin. Okay. Okay, ito, guys, simple regression lang naman, di ba? Una, ang ginamit natin sales sa YouTube. Okay, so yung summary niya, okay, significant, si intercept at saka si YouTube. So ibig sabihin nito, guys, for every 4 centavo, 0.04 or $0.05 investment in YouTube, sales will for every $1 investment in YouTube, okay, there's a corresponding 0.047 increase in sales. Okay. Overall goodness of fit test, okay tayo, no? And significant. Okay, so dito guys, pinapakita lang na yung ano kasi natin, yung model natin fit 1. So we can get the fit 1 coefficients, residuals, at saka fitted values. We have already discussed that before. Kaya nga sabi ko guys, we know this already, so I'll just quickly browse through this. ANOVA guys ng fit 1. Okay, ito yung nakikita natin dun sa results, sa output. Okay, you have degree of freedom 1, degree of freedom 2. Okay, MSR, MSE, F value, and the P value. Okay, we know that the null hypothesis here is beta null is equal to beta 1 is equal to 0. So we reject the null hypothesis. So ito yung equation natin. Okay, and then here we go to the analysis of the residuals. Okay, dito guys, so marketing, we're creating an object. Dun sa marketing data natin, magdadagdag tayo ng residuals, no? So sabi natin dito, i-round off lang natin into 3 decimal places yung residuals ng model natin. Dito naman guys, isasama din natin sa marketing data natin yung we'll call it predicted, no? Dollar predicted. Round off natin, predict function, predict ni fit 1. So ito guys yung residuals at saka predicted. Okay? And then dito, yung sa marketing data natin, and then select natin sales, YouTube, predicted residuals, and then yung head lang. Okay, take note guys, ang deployer natin, no? Ang pinapaprint lang natin dito yung head nung marketing. So run natin to. Okay, so we only have the first 6 elements. Pero ngayon yung marketing natin, kasama na si predicted at saka si residuals. So ito yung sales natin, ito yung predictor natin, okay? Predicted value, residuals. 26.52 minus 21, yun ang residuals natin. Okay. So, ito guys, this is plotting, no? Gusto natin makita. Okay, so GG plot, marketing, smooth natin yung LM. Okay, may color yung smooth line natin. Segment, ito. So, dito guys, pinapadraw ko yung line, no? Geom segment. Yung end sa x-axis, yung pinaka-end niya, yung YouTube. So y-axis, yung pinaka-end niya, yung predictor. May color, may size. Yung line natin, and then may alpha na 0.2. Okay, tapos isama pa natin si geom point. May plus dito guys, may plus. Geom point. Okay, isasama yung residuals, no? And then may scale coloring tayo. Black yung low, high yung red, and then guides, and then geom point ulit, predicted, and shape, theme, black and white. So medyo maanong GG plot, no? But I'm sure you'll be able to understand this. So i-run na natin. Okay, so you can see here, this is the plot, no? Yan. Okay, ito yung yung regression line natin. Okay, then notice guys, yung mga actual values natin, and then yung geom segment natin. Okay, we can see here guys, ito yung line na to, this is our residuals, this is our error term. Okay, so this is the line of best fit. Ito na yung pinaka-best na line na pwede nating magawa, no? Regression line, where the residual squared are minimized. Pag medyo maiba yung slope niyan guys, lalaki yung residual square. That's why it's called ordinary least squares, LEAST, no? Yung pinaka maliit na squared error terms. Okay, so just to illustrate yung ano natin. Okay, dito sa yung augment, naalala nito, augment natin. Okay? Dadagdagan natin Yung sa fit 1 natin, we're creating an object here, model, diagnostic metrics. Let's run this. Okay, so andito si sales, si YouTube, fitted value, residual, standardized residual. Ito yung ginawa natin dati, no? Cook's distance. Okay. So may mga explanation dito, guys. I leave that to you to read, no? Kasi wala na talaga tayong time. Tapos sa ilalim, no? Okay, ito na yung autoplot natin. Di ba? We did this before. So if we run that, this is what we're going to see. Now, sa paper nyo, sabi ko, di ba, magda-diagnostics kayo, you will just have to explain kung may mga violations. But if you want to address that, that will merit extra points. We're going to address that. So dito guys, may mga explanation, no? I will not go to that. Okay, kasi medyo mahaba-haba, no? So ito mukhang ano naman, mukhang linear naman, no? Mukhang hindi naman na-violate yung linearity assumptions natin. It looks like linear, unlike yung previous model natin. Okay, and then yung homogeneity of variance natin, ito, it looks like, no, nagva-violate tayo ng constancy ng variance kasi may fanning out pa rin yung ano natin, yung residuals. Okay, so ito yung mga possible na influential points natin. Okay, and then, okay, now, what we saw a while ago is our graphical representations of our residuals, no? Pwede nating ma-test, for example, yung homoscedasticity. There is a statistical test for that, no? Okay, ito yung NCV, non-constant variance. Okay, that's from the car package. So if we put here the namespace car. Okay, andali, may tanong yata. Yeah, oo. May question si Paul dito, no? So, ang minimum requirement is for us to do the diagnostics, no? Tapos explain. Okay? Now, you may or may not, hindi naman required na i-address yung kunyari, yung heteroscedasticity. How do you address that? Actually, madali lang yun, guys. Ano? Kung i-research nyo lang kung how do you address yung heteroscedasticity issue, that's really very easy to do in R. Maglalagay ka lang ng napakasimple na code. You might want to include that kung yung model nyo, guys, exhibits heteroscedasticity, but that is not required. But if you want, guys, kung i-address yun, may plus points kayo doon. No? Ako, I would challenge you. Pati yung normality, no? Pati tingnan nyo rin, kung may influential, maybe you could go the extra mile and see, what if analysis. Paano kung tanggalin kaya natin tong point na yun? What would have happened kung if a full model natin, tapos tinanggal natin yung point na yun? Would there be more regressors? Would there be more significant regressors? Okay. So I hope that answered your question, John. No? Okay, dito guys, another way to test this is using BP test, no? Bruce Pagan. Sabi natin dito na so meron ngang heteroscedasticity. Okay. Thank you, John. May heteroscedasticity based on Bruce Pagan or dito sa the NCV, non-constant variance test, no? Normality of residuals, guys. Okay, plot then, kung plot natin to, okay, looks like okay naman siya, no? Okay? Hindi naman talaga maging perfect yan, guys, no? Looks like nasa PP plot, quantile plot siya dito, no? Okay, so there is also a statistical test for that, yung Shapiro test. That's from the stats package. Shapiro test. Residuals natin, normally distributed yung residuals natin, run natin. Okay, 0.2133 p-value. Therefore, we fail to reject the null hypothesis that the residuals are normally distributed. As expected, guys, normally distributed yung residuals natin. Okay, so here are some, hindi ko na guys i-discuss yung ano yung kung paano kino-compute yung Cook's distance, yung leverage points, no? You go over this na lang. Okay. Influential points also. Okay, ito yung Cook's distance, guys, no? Ito yung reference si Bruce and Bruce 2017. Okay. Okay, then here you can actually here nakalimutan ko guys ano to check multicollinearity. Although hindi naman natin masyadong problema to kasi 'di ba multicollinearity. Paki-research lang guys, use the VIF function. Okay, you may wish to add this guys, VIF function, variance inflation factor, and read on that. That can be added to your diagnostics to test for multicollinearity. Sorry. Pwede natin gamitin dito yun. Hindi, ang ano pala sa time series, no? It's autocorrelation. So hindi naman natin tinetest dito yung autocorrelation. Ang pwedeng itest nyo guys yung VIF, variance inflation factor. Yata nasali dito, no? That's to test yung multicollinearity natin. Okay, and last guys, dito, yung model diagnostic metrics natin, di ba? Ito yung data natin na merong fitted value, may predicted value. And then pwede natin ilagay dito top 3 weight is equal to Cook's distance. No? So if we run this, okay, ang ibibigay niya sa atin yung data na merong top 3 na Cook's distance. Yan. Okay. Top 3, 0.0389, 0.0605, 0.0563. Okay? Sila yung pinakamalaking Cook's distance, ibig sabihin sila yung pinaka-influential, possibly influential. And then also this one, okay, meron dito mga measurement ng DF betas, Cook's distance, DF fits. Okay. So DF fits. Okay, these are also measures for influential points, no? DF betas. Okay, and here Cook's distance, yung kanina, no? Okay, so I leave you guys to read more on this. Okay, so the last is just exercise. Ito, tinuloy lang natin, no? I leave you to do this, guys. Where we included yung Facebook at saka newspaper. Of course, guys, you can use yung OLSRR, yung ano natin, yung backward regression. Okay, so that ends, guys, our discussion. Actually, sobra na tayo sa time. Pero tingnan lang natin yung logic, guys, quickly. Okay, so when do we do this? Logit model. Hindi na naman nag-run tong ano ko. Nakikita nyo ba nag-run yung ano nyo, guys, yung equation ko dito? May problema tong ano ko. Hindi nag-run. Okay, kay Gracia nag-run. Sa iba, guys, nag-run ba yung logistic? Nag-run sa iba, no? Okay. I don't know, Ken, kung bakit eh. Sa akin din, hindi nag-run eh. Dapat pag nag-hover dyan, nag-run na yan eh. Naglalag lang. Yeah, sige. Naglalag lang siguro, no? Okay, so ito guys, logistic regression din yan, kaso nga lang yung dependent variable natin, binary, no? So this is the complete name of this is binary logistic regression. Okay, so so sige, very quickly lang guys. Medyo iba siya sa regression kasi yung ano natin, binary, no? And the equation here is that your y is equal to ln of p over 1 minus p. Ang tawag dito log odds ratio. P, guys, is the probability of happening. No? May R po. You trans now. Okay. Andali May hinahanap lang ako dito. Okay, anyway, sige. So P is the probability that the event will happen. 1 minus P, not happening yon. So ginagamit natin, guys, yung logistic regression kung yung ano natin, yung dependent variable, yung response variable natin, outcome variable, is answerable by yes or no, mangyayari ba o hindi. No? For example, you might want to do a model kung na ang response variable natin, kung mananalo o hindi yung isang candidate. Or kung papasa o hindi papasa yung isang nag-a-apply sa isang school. Or may cancer ba o walang cancer yung isang tao based on certain parameters. Kunyari yung weight niya, age niya, kung smoker ba siya, kung mahilig ba siya kung anong klaseng sugar. No? So those are the types of researches that can be conducted in binary logistic. Hindi natin pwedeng gamitin yung OLS yan, guys, yung ginamit natin kanina. And this is, itong mangyayari, guys, kung gamitin natin yon, magbabiolate tayo ng homoscedasticity at saka normality of errors. No? So hindi maganda yun, kaya iba yung method na ginagamit doon. So quickly now, guys, paki-run natin, paki-ano natin yung admit, no? Okay. Hindi ko pa pala na-load si admit. So wala pa, bakit wala pa? Ulit. Okay. So is it here already? Ayan na, okay. Alright, so head lang natin, head. Okay. So yung first column natin, admit, ito yung applicant sa isang college, sa master's. So kung na-admit ba siya o hindi, then this is your GRE. It's nakalimutan ko yung pangalan, GRE. It's a rating something, GPA ng college niya. Rank, ang rank, guys, they rank the college, no? From where this person came from. 1 being ito yung magagandang school. 2, hindi masyado maganda. 3 and 4, yung 4 yung pinaka hindi maganda na school. So may ranking na ginamit sila. So gusto natin, guys, mag-model na given a person's GRE, GPE, at saka kung ano yung rank ng school niya, matatanggap ba siya dun sa master's program na yun? Okay, so this is what this does, no? Itong model na to. Okay, so sa structure natin, guys, structure. Okay, if you can see here, admit and rank are integers. GRE, integer yan. Score kasi yan, tama yan. GPA is also correct, quantitative to. Pero si admit, guys, at saka si integer, hindi numbers yan, so i-convert natin as factor. Kaya dito sa next, guys, finactor natin siya. that one admit as factor. Okay, so let's convert it into a factor. Okay, so if we once again check the structure. Okay, so factor na yung dalawa, no? Okay, so factor na yung dalawa. Okay, so mag-create tayo ng two-way table, guys, kasi dapat makita natin. So what we're trying to do here is that tinitingnan natin kung may mga zero or mga small cases. Kasi pag may mga small cases tayo, baka maging unstable yung model natin. So here, we're creating a cross tabulation for admit and rank. So si admit yung dependent variable natin, tapos i-cross tab natin siya with the other categorical variables. Yung rank categorical yan. So i-run natin. Okay? So admit 0, 1, rank 1, 2, 3, 4. So mukhang wala namang 0, no? Kasi guys, sabi ko nga, pag may 0 dyan, baka magka-problema yung model natin. So looks good. Mukhang okay naman yung ano natin. So ibig sabihin nito, from school 1, 28 yung hindi natanggap, 33 yung natanggap. Sa rank 2 na schools, 97 yung natanggap, 54 yung hindi. Sorry, hindi pala natanggap. Baliktad ako. 0 no? So 0 yung mga hindi natanggap. Okay? So sa rank 4, 55 yung hindi natanggap, 12 lang yung natanggap. So that's your cross tabulation, no? Okay. And then, okay, ito guys, no? Ito, I expect you to do this in your model, in your regression model. Ano yun? Kasi ang ginawa natin guys, yung dun sa ano natin, sa wage kunyari, lahat sinama natin ng lahat ng data sinama natin. Actually, hindi maganda yon. Dapat guys, i-split natin yung data natin. Mag-create tayo ng training data at saka testing data. Ano ginagawa nun? Yung imo-model natin, yung training data lang, tapos ita-test natin yung model natin dun sa testing data natin. Okay, so there's a reason for that. Sabi ko nga dito, it's good practice to split data into training and testing data. This will help avoid overfitting your data. Another advantage is to give an estimate of how well the model performs on the new data. So ang ginagawa natin in practice, ini-split natin at saka yung data natin, training at saka testing. So usually ang ginagamit 70-30, 80-20, 75-25. So in this case, gagamit tayo ng 80% na training data. Yun ang imo-model natin. Tapos yung testing data, 20%. Yun ang ite-test natin, yung na-create natin na model, irara natin dun sa testing data to see if okay yung model natin. Okay, so dito ang mangyayari guys, okay, mag-set.seed tayo. Ang gagawin natin, mag-create tayo ng object called ind, no? Magsa-sample tayo, no? Sample ng dalawang samples guys. Tapos end row natin ng data 1 natin is 400, di ba? 400 to. Tapos i-split natin siya into 2, 80% yung isa, 20% yung isa. Okay? So tingnan natin, i-run natin to guys. We will have the same answer kasi nag-set.seed tayo, no? So random to, magra-random siya. Ang gagawin niya, gagawin niyang 1 and 2, no? 1 and 2 yung data natin sa .1. Run natin. Okay, so this is now your .1, no? 400 lahat. Tapos yung ginawa niya, yung observation 1, 1, observation 5, 2, observation 14, 2, observation 16, 2. In other words, nag-randomize siya. Tapos yung 80% dyan, number 1, yung 20% number 2. So, pwede natin split yung data natin. Okay? I hope that's clear guys, no? So, in-split natin data natin. Ngayon, magka-create tayo ng isang object. Ang tawag niyan, train guys. So, it's coming from .1, yung original data natin. Pero yung rows natin, yung manggagaling sa in the object natin na is equal to 1. Okay? Tapos i-test natin from .1 din, yung rows natin, yung naka number 2 lang doon kay ind. Tapos sa lahat ng columns. Okay, include only the rows of that one. Sorry. Tapos of that one, no? Yung data natin na that one. that corresponds to, okay? So i-run na natin to, run. Okay, so let's take a look at our training data quickly, guys. Train. So ito yung training data natin, no? Okay, take note guys na 1, 2, 3, 4. Wala si 5, no? Tingnan nyo. Di ba kasi si 5 pupunta dun kay testing data. Di ba pinoint out ko to kanina? Tapos si 14. Wala rin si 14 dito. Okay, wala si 14 kasi dun siya pupunta sa testing data. Okay? So I hope that's clear guys. Na-split natin yung data natin into training data and to testing data. Let's run test. Tingnan natin. Tingnan yung si test guys. So ito siya. Yung respondent number 5, 14, 16, 26, ito siya. Okay? So guys, pwede nyo gawin, I suggest guys na yun ang gawin nyo rin yan sa regression nyo. Split nyo yung data nyo into two, no? Testing data and training data. Okay, let's continue. Now, magre-regress na tayo. I-regress muna natin sa train. Okay, so let's create an object logit 1. Take note guys, hindi na LM, no? So this is now GLM, Generalized Linear Model. Okay? And then our outcome variable is admit. Tapos ito yung mga ano natin, ito yung mga predictors natin, yung tatlo, GRE, GPA, and then rank. Now again guys, take note si rank, 'di ba? Ano 'yan? Si rank 4 'yan. So magkakaroon tayo ng tatlong variables diyan kasi magiging ano ba yung rank natin? Ang rank natin guys, 3 through si 1 ang magiging reference kasi siya yung quote-unquote alphabetically na mauuna. Okay, so let's run this. Okay. So kakaiba yung result nitong ano guys, no? Itong logistic regression. Instead of residuals, we have deviance residuals. Okay, also sa ilalim, okay, meron tayong null deviance at saka residual deviance. May AIC din tayo. Tapos dito, sa model natin, GRE, GPA, it turns out that GRE is not significant. Okay, importante yung ano dito guys, yung pag-interpret is quite different, no? Ang ini-interpret natin dito, remember, ang y natin is equal to log odds. Yung ln of p over 1 minus 1 plus 1 plus 1 minus p. No? So log odds to guys, log odds. So for example, ano ibig sabihin ng 1.166? What's that? What does that mean? An increase of 1 unit in GPA will mean an increase of 1.166 in the log odds ratio of being admitted to the college, to the master's program. Itong 0.0016 na to, ibig sabihin to, an increase of 1 unit in GRE will means a 0.0016 log odds increase in being admitted, no, to the master's program. Of course, may ceteris paribus. Okay? So itong rank 2 and 3, 4 naman, it actually tells us of the log odds ratio compared to rank 1. So yung rank 2 daw, ibig sabihin, meron siyang lesser chance, no? 0.57 lesser log odds ratio of being accepted to the program compared to rank 1. So habang lumalaki yung rank guys, mas lumiliit yung log odds ratio of being accepted to the admitted to the master's program compared to rank 1. Kasi again guys, gagamitin natin yung reference to. Oo, tama. May question dito si Arnel. Yes, Arnel. Bago kayo bago kayo mag-stepwise regression, no? Naka-split na yung data nyo, no? Naka-split na yung data nyo. Okay, papakita ko dito, no? I'll show it here. Okay, so dito tinagal natin si GRE kasi hindi siya significant, no? Hindi significant si GRE. So, tinanggal natin dito, no? So, I'm going to create sinuproceed ko na lang si logit 1. Okay. So this is now the, so of course guys, si rank hindi natin itong pwede matanggal. Ang sinasabi lang dito, hindi significant yung comparison natin kay rank 2 at saka kay rank 1. Significant yung comparison natin kay rank 3 at saka kay rank 4. No? Kaya, ibig sabihin lang nito, kung hindi significant to, wala tayong, walang difference na nakikita between rank 2 and rank 1. Ito may difference, no? Si rank 3 at saka si rank 4. Okay, so here guys, tingnan nyo na lang dito, no? So, ito may in-explain ako dito, no? Ito, for example, for a 1-unit increase in GPA, the log odds of being admitted to graduate school increases by how much? Increases by, andito siya, 1.37355. Okay, Control C. Pwede natin tong, okay. Yan, okay. And it's increases, no? Kasi positive siya. Yan. Okay, ito. Okay, ito assuming that rank 2 is significant. Ito yung interpretation niya. Assuming na rank 2 is significant, kunyari, 0.57, no? 0.57. So, si rank 2, compared to rank 1, yung, yung log odds niya, decreases by 0.57 compared to rank 1. The log odds of being admitted to the program decreases by 0.57. Kasi nga mas mababa yung niya, no? So guys, iba yung no? Iba itong logistic regression, no? Now what I want to do now is to explain. So hindi ko na yung confidence interval, guys. Okay? Ito, let's create now predict. I-predict na natin, guys. I-predict na natin si logit1. Okay, we'll create an object called P1. Okay? So if you run this, ito yung lumalabas. 0.28, 0.29, 0.68. Ito guys, no? Yung prediction natin, ito yung value ng ng admit natin. It is a probability, no? Probability siya. Hindi ito yung log odds, ha? Hindi ito yung log odds ratio natin. Okay, let me show you, no? Hindi na naman 'to nag-run tong no? Ken, paano mo rin-refresh yung mo? Let me see. I need to, how did you refresh? Sabi mo kanina. Sa session. Okay, sandali. Ito pala yung hinahanap ko kanina. Okay. I don't want to run all kasi restart R lang. Sige. Restart R. Okay, ayaw niya talaga yata, no? Ayaw ko naman i-run all chunks, no? Ayan. Dahil nag-restart na siya. Kaso, pag re-start ko pala, no, mawawala na yung mga objects ko dito. No? So, hindi ko na mararan to. Okay. Okay, dapat hindi ko pala re-start, no? Oh, wow. Okay, sige. Very quickly, ito lang. I'll just run yung pinaka-importante, si logit1. Okay, logit1. Okay, bakit? Hindi ko pa inano si train. Okay. So, ayaw pa rin, no? Okay. Okay, di bali na guys. Ayaw eh. Oh, di bali na guys. Okay na, no? So, never mind. So, ito lang naman guys ang okay. This one guys, di ba I can show you kaso wala na tayong time, ano? We don't have time. I can show you na yung equation natin y is equal to ln of p over 1 plus p. We can solve for p there. Tapos ang lalabas, p is equal to, ito yon, e to the y divided by, ayun mo talaga, p is equal to e to the y divided by 1 plus e to the y. Okay. All right. So from y guys, from y is equal to, di ba yung original equation natin kasi y is equal to ln of p over 1 minus p. Okay. Ito guys yung equation natin, yung model natin. Y is equal to ln of p over 1 minus p. Pag logistic ganito, we can compute for p, no? E to the y over 1 plus e to the y. Now, pag rinan natin yung model natin guys, pag rinan natin, it will give us this one, no? Yung value ng y is equal to this. Pero ang kailangan natin yung p. No? So for example, i-run natin to. Okay. So ito na yung predicted value natin guys, no? Sa number 1, 0.2822956, saan ang galing to? Yung predicted value na to. Saan ang galing tong 0.299? Saan ang galing tong 0.286? Okay. So here, pinakita ko guys kung saan ang galing yan, ano? So for example, i-predict natin si respondent 1. So respondent 1, applicant 1 guys, rank 3 siya, di ba? Rank 3. Okay, kung rank 3 siya, ito yung model natin, ang papasok lang guys, ito, negative 1.6145. So papasok tong si intercept, papasok si GPA, hindi papasok tong rank 2, hindi papasok tong rank 3. Okay, so magkakreate tayo ngayon equation, negative 4.72 plus 1.3735 times kung ano yung GPA niya plus negative 1.1645. Okay, so that's what happened here. Negative 4.727 plus 1.3735 times, what's the GPA of applicant 1? 3.61. Minultiply natin kasi ito yung coefficient ng ng GPA. And then plus kung ano man yung coefficient ni rank 3. Bakit natin hindi sinama si rank 2? Kasi hindi naman siya rank 2, rank 3 siya. Okay? So ito yung guys. If you run this, i-run nyo nga ito guys, control enter. Yan. It's 0.933165. Yun ang y value natin, no? Y is equal to the log odd ratio which is equal to negative 0.933135. Kaso guys, ang hirap i-interpret niyan. Ano ibig sabihin ng log odds, no? That's why what we do is to convert the log odds into probability. So it now becomes a probability kung matatanggap siya o hindi, no? So how do we compute for the probability? We use this equation, di ba yung kanina? So I wrote it here already para mas madali natin magawa. Exponential ng e to the y, okay? E to the y. Ano yung y natin? Ito. Divided by 1 plus e to the y. There. Okay, so when we plot this, guys, when we run this, 0.2822. Yun ang binigay sa atin ni R. 0.2822. Yun. Okay, so alam natin, guys, kung saan ang galing to. No? So, ganun din sa iba. Ganun din yan, ano? And ang tanong ko pa dito, paano si applicant number 3 kunyari? Okay, so yan. Yun guys. So si applicant number 3 naman, si applicant number 3, okay, ito siya. Okay, rank 1 siya. Rank 1, ano? So kung titingnan natin guys yung model dito, anong papasok dito? This one plus this one, and then wala lahat nito. Walang papasok dito. Okay? Kasi ito rank 2, rank 3, rank 4. So this will zero out, 0, 0, 0, and it means si rank 1 lang siya, no? So that's why ito nangyari dito, no? So negative 4.72 times 1.3735 times yung GPA. The GPA is 4. Yun. Okay? I know guys na medyo mabilis yung pace natin, pero since andito naman yung notes na to, you can of course follow along. So ito yung Y, no? I-convert natin sa P, 0.6828. Kaya ang lumabas doon, 0.6828. Yun ang galing yun dyan, guys. Ito yun. Okay, so alam natin ang galing. Kung saan ang galing yung mga yan na predicted value ni R. Hindi siya yung log odds, but they are now the predicted probabilities. Okay, so dito na ang gagawin natin, guys, gagawa tayo ng confusion matrix. Ito na ang magsasabi sa atin kung tama ba o mali yung prediction ng model natin. So let's create this object pred1, okay? If else. Sino yung P1, guys? Si P1, ito yung mga predicted value natin, yung 0.28, etc. If it's greater than 0.5, ibig sabihin, 0.5 yung ano natin, yung cutoff. Pag 0.5, maa-admit sa college. Probability kasi ito guys. Kung if the probability is greater than 0.5, gawin natin 1, ibig sabihin yes, maa-admit. Pag less than 0.5, isi-zero natin siya, ibig sabihin hindi maa-admit. Okay, so that's what's happening now. Pred1, ano natin head pred1, head pred1. Okay, so ito siya, no? Ito yung first 7. Okay, 1, 2, 3, 4. Tingnan nyo, wala yung 5 guys, ha? Kasi trained data to, no? So 0, yung 0.28 kanina ginawa niyang 0. Ulitin ko, ha? Okay, 0.28. So dapat 0 to kasi less than 0.5. 0 din to. 1 to. 0, 0, 0. So anong nangyari guys? Kinonvert na niya yung mga probabilities into 0 or 1. Yan, ito na yun. Okay? And then dito magkakreate tayo ng table. Ito table function. Tab 1 ang pangalan. Okay, ipagsasama natin si predicted. Ang tawag natin sa kanya, si pred1. Ang tatawagin natin predicted. At saka si actual. Sino ba si actual guys? Galing siya sa trained data natin, yung admit, no? Yung 0 or 1. Tapos i-compare natin. Ang gagawin natin, isa-sum natin yung diagonals ng tab 1 over sum ng tab 1. Pakita ko na lang to, no? I-run natin lahat. Run natin lahat, guys. Okay, so what do we have here? Okay, this is what we call the confusion matrix. Okay, ano to? Ito yung actual 0, tapos actual na 1. 0 yung hindi na-admit, 1 yung na-admit. Yung predict natin, no? Yung predict natin, ito, predict natin na hindi siya ma-admit, tapos actually hindi siya na-admit, 208. Okay, so itong mga diagonals dito guys, ito yung tama. Predict natin na 0, tapos 0 talaga siya. Predict natin na 1, tapos 1 talaga siya. So ito yung mga tama natin, ito yung mga mali natin. Yung sa model natin, predict natin na 1, pero ang actual niya, hindi siya natanggap. Tapos, ito naman, predict natin na hindi siya matatanggap, pero natanggap siya. Alright? So yung tama natin, 72%. Okay? Because we just got the sinum up natin to, okay, sum ng diagonal ito, divided by yung total. Okay, 208 plus 29 plus divided by the total, yun ang tama natin. So yung mali natin, 1 minus that. No? So 73% yung correct na na ano natin na predict, 27% yung hindi. Okay? All right. Then what we do, guys, is to i-test natin yan sa test data natin. So you do everything for the test data. Okay? Predict din natin. So ang lalabas dito pag ano natin. Okay, ito yung test data natin, guys. So dun sa tinest natin, yung test data natin, 71% yung tama, 29% yung ano. Not bad, guys. Ibig sabihin, yung data na first time na mamimit ni R ng model natin, na correct niya 71%. Yung 71% yung tama niyang na-predict, 29% yung hindi. Okay? So not bad, guys. Very good yung ano natin. Okay, so ito, guys, I leave this to you. So dito pinapakita lang dito yung overall goodness of fit natin. Okay, the p-value is 1.45 to the -6. So mataas yan, ano? Mataas. Chi-square natin is 32.59. So dito sa logistic regression, ang ginagamit hindi F-test, no? Chi-squared ang ginagamit na ano, with 4 degrees of freedom. It tells us that our model as a whole fits significantly better than an empty model. Okay, so sino mas maganda? Wala tayong predictors or itong model natin na kasama si GPA pati yung rank. So, ang sabi dito, mas maganda tong model natin because of the p-value. Overall goodness of fit din to, guys. Okay, tapos ang ginagamit dito hindi yung OLS, no? It's hindi yung minimum yung least squares method, no? Ang ginagamit dito is the likelihood ratio test. Okay, so that ends, guys, our logistic regression. I don't think any one of you will do logistic regression, ano? So okay lang yun. All right, now let's not anymore transfer to the other, ano, guys. Okay lang siguro na isang recording na lang to kasi wala na tayong time. Okay, okay lang ba yun? Okay lang ba yun na ano na itutuloy-tuloy na lang natin? Okay, sige. Okay. Ken, kasalanan mo kanina kung bakit ako nagtagal, ha? Pina-refresh mo ako eh. Actually, guys, sa totoo lang, matagal ko nang hinahanap kung bakit last term pa, no? Hinahanap ko kung bakit pag rinaran ko tong pag nag-open, hindi nag-i-inline siya, hindi siya up to now hindi ko pa ma-discover, no? So kung may makakita sa inyo kung bakit na hindi ko yung sa inyo nagbubukas naman, di ba? So sa akin hindi nagbubukas, no? Okay. So sige, punta tayo, guys, sa yung sa isang natin. Unahin muna natin si tanggalin ko na itong mga objects na to, no? Train, test. Okay. Unahin muna natin, guys, si importing kasi si Quantmod mas madaling kahit hindi natin ma-discuss ng konti, mas madali nyo masundan. Ito medyo mas mahirap-hirap sundan to, no? Okay. Let's go to this ang objective natin dito, guys, we only have mga 40 minutes na lang, 40 to 45 minutes. Ang objective natin dito sa model na to is to know how to import data, how to collect data, and to economic data or financial data from different sources, no? Okay, so nag-open ako, nag-get symbols kagad ako dito. Okay, sandali, punta muna tayo dito, guys. Sorry sa Quantmod, no? Let's go to Quantmod muna. Siguro ito muna talaga dapat ang kukunin ko. So let's run this. Quantmod and TTR, guys. Technical trading in R. So this is also a very powerful package. I don't know kung tapos sa kayo invest na or may elective kayo na technical trading. This, guys, will be your Bible, no? Kung nag-R yung teacher nyo. Pero sabi ko nga sa inyo, guys, empowered na kayo ngayon eh. Kasi ang dami ng tutorials on Quantmod and technical trading in R. You'll really learn a lot, guys. Okay, so dito, ano ba yung data natin dito? Hindi ko pala, nabigay ko ba sa inyo to? Sandali, let me check. Okay, sandali, quickly, guys, i-send ko na lang sa chat dito. Sandali. Sorry. Kanina pa ako nagsasalita, nakamute pala ako. Okay guys, sorry ah. Ang sinasabi ko, hindi ko pala nabigay sa inyo yung data na to. Hindi ko makita guys, but it's okay. Hindi naman siya kailangan kasi it's just a math. It's just dinownload lang natin from Yahoo Finance yung data. Tapos linode ko lang dito, in-import ko lang. No? Siguro after this, ipopost ko na lang siya. Ang importante sa atin itong get symbols, which is from Quantmod. Okay, Quantmod allows us to get data, economic financial data from different search engines. Sabi ko si Google, tinigil na niya yung ano eh, this does not work anymore. So sabi dito, error get symbols is defunct, no? Ito naman, okay. How about this? Okay, sabi dito, hindi daw niya makita yung yung AABA. Ito din nagtataka ako bakit hindi makita yung this is alphabet, no? Pero tingnan natin to. Let's take a look at this. Source to Yahoo Finance. Control enter. Okay, so this we now have this Google data. Okay, anong klaseng data siya, guys? It's an XTS dataset, extensible time series. Okay, extensible time series. So ang default niya, ibibigay niya sa atin yung data from 2007, January 3, first trading day ng January 27, hanggang yung most current date, May 27. Okay, so if I click this, let's click this, guys. Ayan, no? So we have the opening price, high, low, close, number of shares traded, and then adjusted price, no? Teka muna guys, are you sure na hindi pa natin na-discuss tong Quantmod? Sure ba? Paki-chat nga, baka, sorry na, medyo na-disorient lang ako. I'm not sure kung, ayan, okay, good. Okay, kasi kung na-discuss na natin, so, okay, but guys, I guarantee you guys, ang laking tulong nito, itong Quantmod na to. And since we only have really a few minutes, I'd like to encourage you to really go through yung YouTube. Ang dami ng mga tutorials dito. Malaking kadagdag yan sa skills nyo guys, sa skill sets nyo. Okay, so let's go here. Let's continue. Okay, if you want to get different prices, no? So ito get symbols. C, combine AABA, Google, Amazon, Microsoft, and GSPC is S&P 500. Okay, so let's run this. Okay, hindi nagra-run si, nag-fail si AABA kanina pa to. No? Tanggalin na natin guys si AABA. So, 4 na lang na stocks, i-run natin. Oops, what? Ano nangyari? So, si Amazon nag-run, GSPC nag-run, Microsoft nag-run. Bakit si Google hindi nag-run? Okay, any mistake dun sa ano ko? Google, Amazon, Microsoft, GSPC. Okay, I have here andyan siya, no? Okay, alright. Nag-run naman, no? Nag-warning lang siya. But it did run, no? Nag-run siya, no? Ito, Google, Amazon, Microsoft, GSPC. Okay, so andito na si Amazon, guys. And here's Amazon, no? Okay, so pag na-import nyo na to guys, ang dami-dami nang pwede nyo magawa dito, no? Dito na yung pwede tayong mag-time series analysis, which hindi natin sakop ngayon, but that will be your lesson next term, whoever your teacher will be. No? So, pwede natin i-bar chart, for example, si Google. Okay. Bar charts to, no? Masyado lang kasi from 2007 to, no? So, hindi natin masyado makita. But if we will change the range of date, mas makikita natin yan. Ito naman, Quandl chart, guys. Multicolor is equal to true, team is equal to white. So let's run this. So this adds multicoloring and changes the background to white. Okay. So if you can see this one, guys. All right. So si Google, over time, tumataas yung stock price niya, no? And this is the volume. Ito yung number of shares na trade, no? So kasama yan sa pag-plot, no? Dito sa Quandl chart. Sa bar chart, kasama din yung volume, no? Okay, any questions so far, guys? Chat. Any questions so far? Okay, good. All right. Ito guys, pag set symbol lookup, no? Let's not go here. Hindi pa naman masyadong importante sa atin yan. Mas importante sa akin to, no? Okay, get symbols GS. This is Goldman Sachs, no? From Yahoo. Okay, let's take a look at this. Okay, sabay-sabay na natin i-run to. Okay, we're able to get hindi na ano tong iba ito. Okay. So this one okay, get symbols GS. So meron tayong GS dito. Ito. You have an object here. GS. Then is it OHLS? If you notice guys, yung prices ng mga stocks natin. Tingnan niyo, open, high, low, close. This is called the OHLS method. Open, high, low, close. So dun sa tinanong natin kanina is OHLS GS? Okay. Does it contain OHL and C? Ang answer, yes. True. Tapos, next question. Meron ba daw siyang volume? Has volume? Yes then, kaya true. No? Okay, then ito. Let's create an object called OpenGS. And this is the opening of GS. So, if you run this, guys. So, meron tayong object na opGS. This one. So it only contains the opening price, no? So pwede natin ma-subset yung data natin very easily. Yan. Add, ito yung adjusted price. Okay? So if I run this, makukuha lang natin yung adjusted price ng JS. How about this series high? Ano ibig sabihin ng series high? The highest point dun sa natin sa GS natin happened on May 10, 2021. So highest close on 368.68. And then lowest dun sa lowest happened on during the financial crisis November 21, 2008. Tapos series ito yung plot din kanina, chart series natin. Yan. Okay? So guys, I wish I have really more time to discuss so many features of Quantmod, but I hope you'll keep this in your arsenal and pag kunyari nagta-time series na kayo next term, mag-practice kayo ng time series data using Quantmod by getting prices. Tapos kasi imo-model nyo yung time series, magkakaroon kayo ng ARIMA model, no? Autoregressive integrated moving average. Remember that term kasi babalikan nyo yan guys sa FinStar. Tapos pati yung kunyari yung GARCH, kung aabot kayo ng GARCH, which models volatility. Okay, so malaking tulong yung you might be using a different, depende sa teacher guys, Hindi kasi lahat nag-AR, no? Normally, pag ako nag-handle ng FinStar, but I don't think I'll be handling FinStar next term. So, at least opportunity to learn another software kayo, no? So guys, if the teacher will not use R, please do not take it against the teacher. Take it as an opportunity to learn another software if it's another software that the teacher will learn. But please do not sorry. Wag niyong lulubayan guys yung pag-aral ng R nyo. Make it really your goal to learn more. In fact, I'll be requesting Mafia to conduct an activity. Tapos, particularly for my students na nag-R sa akin, so magkakaroon tayo siguro ng seminar or workshop where we do structural equation modeling kasi parang enhanced na regression yun eh. Yun kasi sa SEM guys, maraming networks ang pwede. Sa atin guys kasi independent tapos dependent. So kunyari yung model natin, 6 na independent, may arrows lahat papunta sa dependent variable. Yun lang yun. Pag SEM, after the dependent, pwede pang may isang dependent. Tapos may isa pang dependent ulit. So that's how powerful structural equation modeling is. Hindi ko lang alam kung iti-take nyo sa FinStar, no? Okay, how about this guys? Open, close, GS. So ano to? So this one gives us, no, tinan nyo. So open and close, ibig sabihin kukunin niya yung percentage change, no? Percentage change or difference ba? Kasi tingnan natin si GS guys. So open, close, 200.72 divided by 200.60. Dali. Sorry, this is Control C, Control V, divided by this one. Percentage change lang naman yan. Minus 1. So that's 5.984 times 10 to the 4th power, which is this one, di ba? Which is this one. Yan, no? 5.982. May konting difference kasi. Kinapi lang natin yung na truncated na value. Okay, anyway, yan naman sinasabi niya, no? You can easily get the percentage period open to open change, percentage change from high to close, okay? And then this one for subsetting. Okay, kung gusto natin na lahat lang ng prices ng Goldman Sachs noong 2007, in fact, pwede tayo mag-create dito GS2007. Kung gusto lang natin yung data natin na 2007 lang, you can do this. So GS2007, 2007 lang lahat to guys, 251 entries. So very fast way to subset, no, using Quantmod, okay, etc. No? So I won't continue with this anymore, guys. Pwede nyo makuha yung last observation. Kailan ba yung last observation ni Goldman Sachs? Nung May 27. May 27. Pwedeng last 3 weeks, pwedeng all except last 3 weeks, pwedeng last 3 months. So, guys, ang Quantmod is a very, very powerful model. So, ito din, importante, guys. Ito, I'll end in this, no? Periodicity ni Quantmod is, ni GS is daily siya. Daily, no? Daily periodicity. What's good about this is that ito, si Quantmod, it will allow us to get also weekly data. Weekly data, monthly data, yearly data. Okay? So, itong ano ginagawa nito, no? Unclass. So, anong ibig sabihin niyan, guys? It tells us some information about, ano? 86,400 frequency from January 1, 27 hanggang May 27. Okay. Units are in days, no? Okay. Parang ano natin yung structure niya. And then ito guys, ang kagandahan nito, so let's say GS weekly. Okay, GS weekly to weekly GS. GS weekly. Yeah, take note guys. You have now weekly data. Okay? So may weekly data na kayo dito. Kung gusto nyo monthly, monthly. Okay, so that's the beauty of you can easily get information from the internet to R, then to subset. No? Ito to monthly then, to weekly. Ito to weekly lang ng 2020, no? GS weekly 2020. Okay. Kasi kanina lahat, di ba? So GS weekly 2020, ito. There. 2020 lang siya na weekly. Okay? So I think the rest are quite self-explanatory. Okay? Okay, then you can also get data hindi lang from ano no from Google, no? Ito let's see, get FX. You can also get exchange rates. So hindi lang sa ano, hindi lang guys sa ano sa hindi lang sa Yahoo Finance pati kay Fred, yung Federal Reserve Bank sa St. Louis, maraming information din doon. And then you can also chart. Ito maganda yung charting function ni ano, charting function ni Apple, no? So may Apple na tayo kanina, di ba? So i-chart natin si Apple for example ng ano lang ng oops. Kinuha wala pa pala tayong Apple. Get symbols, Apple, chart series. So ito yung chart series ng Apple. And then candlestick there. Okay, naiintindihan niyo ba guys yung candlestick? Ano ibig sabihin nito? Kung green o orange, ibig sabihin pag ano guys, pag green, tumaas yung price, no? Tumaas yung price. Yung ano dito, ano ibig sabihin ng mga ano, ng mga yung wick at saka nung candle mismo? So may ibig sabihin yan guys, no? Remember you have OHLC yan, no? Open, high, low, close. Okay, so but I'll let you explore kung ano yung ano to? Ano to? Okay. So this is always the opening. Yung ba? Opening? Yung ano to? Low. This is the high. Diba? Ano to mga to? Opening, closing. Bakit alam ko opening, closing to? Kasi pula siya, green siya, ibig sabihin tumaas. Ito naman guys, open, open. Ang open nasa taas, ang close nasa baba. Kasi orange siya, ibig sabihin bumaba yung price. So yung wick guys is high, low. Tapos yung candle mismo is open, close, close, open. Pag orange yan, close, open. Ibig sabihin, bumaba yung price. No? Okay. And many more, guys. Okay. Sayang wala na tayong time para makita yung Bollinger Bands. No? Very, very interesting, guys. Kunyari, i-plot ko lang to. Just to show you the power of TTR. Yan. Kita nyo, guys, yung mga MACD natin at saka yung Bollinger Bands. No? And this can be done in TTR and Quantmod. Okay, so that ends our discussion here. So I have a few more minutes to discuss yung last topic natin. Okay, so far ba guys? Okay tayo? Paki-chat nga kung okay so far. I know that it's already almost time, and then since 7, almost 7:15, 7:20 pa tayo. So almost 2.5 hours na tayo, no? Okay. So but I'm happy that you're still there. You're still here. Okay. So last, guys, ito na, no? Di ba, dinownload nyo ba yung ano, yung nag-ano ba kayo ng API key nyo, guys, sa Alpha Vantage at saka sa ano? Okay, good. I'm happy that you registered dun sa Alpha Vantage at saka dun sa Quandl, no? So these are other sources of data. By the way, guys, si Fred, importante sa atin yan. Kunyari si Fred, no? Ito si Fred. This is Federal Reserve Bank of St. Louis. Ang daming data dito, macroeconomic data. May Philippine data din dito, no? So it will be good for you to explore kung ano yung mga makikita yung data. Pati si Wanda, no? Si Wanda naman, karamihan data sa kanya yung mga exchange rates, no? So titingnan din natin si Wanda now. Okay? Dito tayo sa importing financial data. Okay, so sabi natin si get symbols function from Quantmod provides a consistent interface. So okay na okay to, guys, para mag-download tayo ng data. One good thing is that yung get symbols, guys, from Quantmod gives us an XTS object. So extensible time series object. By the way, nasabi ko ba sa inyo? Tingnan yung extensible time series object, ha? Napansin nyo, guys, na yung index natin, yung date, hindi siya kasama dun sa columns. Naka-separate siya. Napansin nyo, guys? Yan, o, tingnan nyo. Yung index natin, kapag zoo object or extensible time series object, yung ano natin, yung index, which is date, no? Index tie by date, eh. It's not part of your data. Okay? Naka-index natin yan. Kaya magandang gamitin to yung XTS object, guys, for time series. Unlike ito, si Quandl tayo, ito yung disadvantage ni Quandl, no? Okay, so let's quickly do that here. Okay, si QQQ is a ETF siya, Exchange Traded Fund. Trinatrack niya si Nasdaq 100. So siguro naman na-meet yun na si Nasdaq, no? Yung mga online stocks to na traded sa US. Okay, so na-load na natin si Quantmod. Okay, let's run this from 2007-11 hanggang end lang ng 2000, ano? Okay, so this is QQQ. Okay. Okay, so open, high, low, close, etc. Again, yung index natin. 3,523 observations hanggang December 31, 2020. Kasi yung sinabi natin na from at saka to. Tingnan nyo, guys, oh. From to. Okay, structure. Ano yung structure nito? XTS object containing high, open, high, low, close, etc. Okay. All right. The source argument allows us source, not search. Okay. Punta na tayo, guys, sa Alpha Vantage. Now, may package na ang tawag sa kanya. Paki-install nyo nga to, guys. Alpha Vantager. Okay. So, ito na yung sinabi ko sa inyo, guys, na you get your free IPI. Tapos, kunin nyo, guys, yung IPI nyo. Kunin ko muna yung IPI ko. Okay. Pause ko muna to, no? Get your IPI, please. And then once you get your IPI, guys, i-run nyo na to, no? I-run nyo yung library na Alpha Vantager at saka yung ano nyo, yung key. Okay, na-run nyo na, guys. Have you run it, guys? Okay, good. Okay. Kailangan natin i-run yan, guys, kasi hindi tayo makakakuha ng data from Alpha Vantager. Okay, I leave you guys to explore kung anong laman ng Alpha Vantager. No? Okay, so, pag na-run na natin yung, wait. Okay, can you now see the screen, guys? Kita na ba yung screen? Okay, thank you. Now take a look at our first, let's create an object called M1, and we're going to use Alpha Vantager get. No? So we can also get stock prices from Alpha Vantager aside from Yahoo Finance. No? So symbol is equal to MSFT. AV function is equal to intraday. Ito yung advantage, guys, ng Alpha Vantager compared to Yahoo Finance. Kasi sa Yahoo Finance, hindi natin makukuha yung intraday. No? Ito interval 15 minutes. No? Output size is equal to full. We cannot do this in Yahoo Finance. Hindi natin makukuha yung every 15-minute data natin. So let's run this. Okay, it will take a bit of time. Okay, so andyan si M1 natin, M1. Tingnan nyo guys, no? Is this M1? Take a look at this, guys. Okay, from April 4, April 14, 2021 hanggang May 26, 2021, it gives us the, okay, 15-minute interval, guys. No? 4:15, 4:30, 5:30, 5:45, 6:15, 6:30, 6:45, 15-minute interval. Okay, ng mga prices, open, high, low, close, no? Tsaka yung volume din. So this is not possible, guys, sa Yahoo Finance. Ang sa atin, daily lang sa Yahoo Finance. But with Alpha Vantage, to the 15-minute. So kung kailangan mo mag-model ng stock price na by the minute, guys, ito nga 5 minute, tsaka itong 1 minute. Iran lang natin yung 1 minute. No? M1, M1A. So M2A pala, M2A. Okay, tignan nyo guys, to the minute, 13, 14. You have only, kaso nga lang, 100 entries ang ibibigay niya. No? 100 entries. But still, this is to the minute. No? So that's the advantage. That's why I asked you guys to get your API key from AlphaBand, yung application program interface, no? Yung API. Total libre naman yan. No? And you can also get daily adjusted using the AV get, parang nasa taas. Ito time series daily adjusted. Ito time series intraday. So let's quickly run this. So saan yan? M3. M3. Okay. So this is from January 5, 100 entries. Okay, I think ito yung limitation ng no, ng if you want to really get if you want to really get yung daily prices, then mas maganda mas maganda kay Yahoo Finance. Kaso nga lang kay Yahoo Finance wala yung dividend amount at saka yung split coefficient. Okay? Yung split is equal to 1, ibig sabihin walang split 'yon. No? Remain the same pa rin. Pag 2, ibig sabihin na split into 2. Or pag 1/2, merong 1/4, 2. Okay, so, and notice guys, this is a data frame. No? Tinan yung timestamp, it's part of your data frame. Unlike kung dun sa get symbols, kay Quantmod, the date guys is part of is the index. Itong index niya, numbers lang. No? So this is a data frame. So when you're analyzing time series, mas maganda talaga kung XTS yung object. So this is the disadvantage here. Okay, so a few more guys. Alright, so dito tayo. Ay, porting pala tayo, no? Okay, ito naman, may quote endpoints naman. So let's run this. One object lang. Okay, Microsoft endpoints, no? So open, high, low, closing price, volume, latest dun sa latest day, 21, previous close, 251.49, change, -2, change percent, no? So maraming information tayo nakukuha. Kasi this is more for trading, no? Malaking makukuha dun sa data when you're looking at daily trading, tapos yung mga information na kailangan mo, ilang binaba, ilang percentage yun. Alpha Advantage has its strengths, no? Okay, dito naman guys, ganun din kay Alpha Advantage, exchange rate naman to. Okay, so I'll leave that FX intraday then. Okay, 5-minute intraday, parang yung kanina sa stock. Tingnan natin to, euro dollar, FX2. Okay, so ganun din, no? So this is euro to the dollar, no? And then you have here my every 15 minutes. Okay, so okay, it's almost time. So may daily din tayo. And then may mga technical indicators tayo dito. Kunyari itong simple moving average. So here from AV get, let's get Microsoft. Ang function SMA, okay, interval weekly, time period 10 weeks, no? And then series type open. So let's run this. And then SMA1, let's open SMA1, ito. Okay. So, simple moving average to guys, ibig sabihin nito, by by 10 days to, 520, but kaya 6 lang, no? Ano ba nilagay natin sa code? 10 days? Weekly pala, no? Weekly, by week, no? So weekly na 10 weeks. Okay? So anyway, ito yung SMA to guys, simple moving average. Ibig sabihin, in average yan last 10 weeks. Okay, last 10 weeks, tapos every week, gumagalaw yung last 10 weeks na yun. Okay, so that's what that means, guys. Nag-technical analysis ba kayo, guys, in any of your subject? Nag-technical analysis kayo? Meron? Okay, meron yata, no? Nag-technical analysis ba kayo? Okay, good. So, yung aralin nyo guys yung TTR na package, ang daming technical analysis na pwedeng gawin dyan, no? Kaya ang tawag sa kanya technical trading in R. So ito guys, si Fred naman to, no? I'll just leave you to get this example. Ito yung Wilshire 5,000 guys. It's a benchmark for all the stocks in the US. So, okay, tingnan nyo na lang siya, guys. Okay. So, kanina ang ginamit natin si Alpha Advantage. Ito naman si Quandl. Ganun din, guys, ipapasok nyo yung API key nyo. No? After you registered, install nyo si Quandl and then put your API key here. And then, marami tayong makukuha dito. No? Kunyari, oil prices. Okay. Then you can plot yung oil prices coming from Quandl. Okay, let's, may I have last 2 minutes, guys? Pakita ko lang yung simula ng Quandl. So could you kindly get your API key sa Quandl? I'll get also mine. Once you get your API key, i-run nyo guys, no? Okay, sorry na naman guys. Okay, thank you. So I was saying guys na once na-install nyo na si Quandl, ipasok nyo yung API key nyo dito sa quandl.api._key. No? Pag pinasok nyo na, then go to, kunyari gusto natin kunin yung oil prices. No? So go to Google, i-google nyo guys. No? Oil price Quandl. No? Oil price OPEC Quandl. And then you go there. Okay, thank you. You go there and then copy this. Ito yung code, no? Kakopy nyo to. Tapos, yun ang ipasok nyo dito, no? Quandl, code is equal to. Or pwede nyo nang tanggalin din si code. Pwede rin yan. This will also work or code is equal to. So when you run that, guys, yan, ma-generate na yung oil object. Oil. So ito na siya, as I said a while ago, 4,745 observations from January 2, 2003 hanggang yung latest May 26. No? So very easy to get data. Pwede natin i-plot. Then pinat ko kanina, ayoko nang una kasi ang default niya parang circles yung 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 plot. So ginawa kong type is equal to L line. Yan. Okay, as you can see here guys, andito yung andito yung global financial crisis, no? The price of oil really went up. Tapos 2000 I don't know if this was the start of the financial crisis. No? It would be interesting to know when this period is. Tapos ito yata yung ano ba to, yung I don't know when this is, but we can study this, na pwede yung aralin kung kailan to. That's easy to do. All right, so in difference lang guys ang get symbols at saka Quandl. So pag get symbols, di ba, kailangan natin ipasok yung symbol pati yung yung source. Kay Quandl, yung code lang. Yung code. So for example, this will give us the same output. Okay. So I think that's about it, guys. Okay, so there are some more notes here. Also from Wanda, ito yung sinasabi ko sa inyo guys, si Wanda, dito tayo makakuha ng maraming exchange rates. So may mga example dito. For example here, this is an example of getting information from Wanda. Okay, so with that guys, we end our discussion. Just go through this one. Okay, so thank you so much guys. Maraming salamat sa pag-attend. I hope you learned something. I hope naging worthwhile naman yung natin, yung term natin. It has been fun being with you guys throughout the term, and thank you so much. Okay, so I'll see you next. Thank you guys. I'll see you next week guys for the finals na, no? Wala na pala tayong session, but kung may mga questions kayo, feel free to ask questions. Thank you, Arnel. Thank you. Sejin, thank you. Hazel, thank you. Ken, thank you. Bea, okay lang, no? Sige lang, if you have questions. Thank you all. Maraming salamat. Hindi ko na nasundan guys. Thank you sa lahat.